Welcome, everyone. Thank you for joining us for OA Week 2023. My name is Dr. Shaima El-Gamal, and I am a coordinator on OA Week 2023. Please note that this session is being recorded. OA Week is presented by 4 sponsoring organizations. First, GOA-ON, the Global Ocean Acidification Observing Network. Second, NOAA, the United States National Oceanic and Atmospheric Administration. Third, the International Atomic Energy Agency, Ocean Acidification International Coordination Center. And last but not least, the IOC UNESCO, the Intergovernmental Oceanic Commission of the United National Education, Scientifique, and Center Organization. GOA-ON was established in 2012 with just a handful of members. Since then, GOA-ON has grown immensely. It now has over 1,000 members from 114 countries. GOA-ON also consists of 9 regional hubs, which span across continent and oceanographic regions. We will be hearing from most of them through OA Week. If you are not a member yet, you can join GOA-ON today by visiting goaon.org. OA Week debuted in 2020 and returned in 2021 when events and conferences were postponed due to COVID-19. Following the successful in-person symposium on the ocean in a high carbon dioxide world in 2022, GOA-ON is bringing back an OA Week 2023 to maintain momentum around OA research and provide a virtual platform for the ocean acidification community to exchange their latest findings. We are thrilled to present a wide range of ocean acidification topics and speakers from around the world. During the presentation, all participants are in listen-only mode. You are welcome to type any question into the question box, which can you find at the bottom of the control panel in the right-hand side of your screen. You will be monitoring incoming questions and will pose them to our speakers during the question and answer section, which will begin immediately after the final presentation. For discussion, you can also use the raise hand function in the toolbox at the bottom of your screen, and we will call on you, ask your question directly. And with this, I'd like to introduce to you, we have 2 moderators for this session. First, Dr. Nathalie Hilmi, an expert in macroeconomics and international finance. In 2010, she joined the Center Scientifique de Monaco as section head of environmental economics and collaborated with IAEA environmental laboratories to initiate correlation studies between environmental science and economics. She passed her postdoctoral degree on sustainable development. She led author for the IPCC special report on climate change, ocean and the cryptophyte and the AR6 WGII. And we have another moderator, Dr. Pipi, is a professor of biological science. At IISER, Kolkata, India. He also chair for South Asia Region Hub on Ocean Acidification, SARO. Welcome, our moderator. The floor is yours.
Hello and welcome to this session on the socio-economic impact of ocean acidification. We will have 5 speakers, and I want to call the first one, which is Olga Anghelici. She is currently acting as Associate Project Officer within the framework of the Ocean Acidification International Coordination Center of the International Atomic Energy Agency. In this role, she is responsible for overall project implementation, partner and donor liaison, and communication and data management. She's an experienced international development professional with a solid background covering diverse thematic areas such as sustainable development, ocean acidification, public health, partnerships, and communications, acquired over years of United Nations assignments carried out in Vienna, Monaco, Geneva, and Chisinau. Her career in the United Nations system started in 2011 and unfolded within specialized agencies such as IAEA, UNOPS, UNFPA, and UNODC. A versatile project management specialist, she has contributed to and led a wide range of multidisciplinary cross-sectorial activities in development cooperation. Her expertise also spans across gender mainstreaming, social policies, vocational education, and lifelong learning. Today, Olga will present about how the IAEA, through the OA-ICC and otherwise, addresses the broader socio-economic impacts of ocean acidification. Olga, the floor is yours.
Good afternoon, Nathalie. Good afternoon, colleagues. I'm very pleased and privileged to be part of this session today. Please allow me to share my screen with you. Yes, thank you very much. So as Nathalie mentioned, I will be referring to the ways in which the IAEA addresses the broader human dimension and socioeconomic impacts of ocean acidification. And I will start with a little intro on the IAEA architecture and the place of the OA-ICC within. So the slogan Atoms for Peace and Development describes very well the very mission of the IAEA, which is to promote the peaceful uses of nuclear science and technology in order to help member states advance in their development goals towards ensuring the well-being and prosperity of their people. So the transfer of nuclear science and technology to member states is a core IAEA mandate and constitutes a substantial part of our activities. The Department of Nuclear Sciences and Applications works across a range of socioeconomic sectors, from food and agriculture and human health to environment and water and sanitation, assisting member states in tackling important challenges and needs in these domains. It also works with laboratories, research centers, and institutes worldwide through a particular scheme called IAEA Collaborating Centers. The IAEA has played a key role in marine protection and conservation for more than 6 decades now. The IAEA Marine Environment Laboratories, which are unique laboratories within the framework of the United Nations Common System, have been producing essential scientific data on environmental pollution, the carbon cycle, and ocean acidification. And it is important to mention that since 2010, the IAEA has implemented more than 90 projects targeting building capacities in member states for the peaceful uses of nuclear science and technology related particularly to the protection and conservation of their marine resources. The Ocean Acidification International Coordination Center is localized within the radioecology laboratory and was designed to serve as a global hub for a coordinated action in the field of ocean acidification. Why the OA-ICC at the IAEA? Well, first, it is important to say that in order to develop and implement effective solutions, we need to understand the underlying drivers for biological processes. And nuclear and isotopic techniques have proved themselves as reliable and effective tools in the study of these phenomena. For instance, Carbon-14 is very effective in helping assess phytoplankton growth, while calcium-45 is used to measure calcification processes. Boron isotopes are useful in measuring historical pH, so they represent a type of window into the past, allowing us to assess past ocean acidity and past ocean acidification events. My apologies. So the Ocean Acidification International Coordination Center has three main pillars of activity: science, capacity building, and communication. When it comes to science, the OA-ICC offers a range of unique resources: a bibliographic database comprising more than 10,000 references, a data portal on the biological response to ocean acidification, collecting data from more than 1,400 research papers. The OA-ICC is also contributing to the Global Ocean Acidification Observing Network and its 9, soon to be 10, regional hubs, and it is also actively engaged in the development of best practices in research and data management. Capacity building is a core activity of the OA-ICC, and over more than 10 years of existence, the OA-ICC has trained over 800 scientists representing more than 100 IAEA member states. Training ranged from conducting hands-on experiments to managing data and communicating results to various types of stakeholders and audiences. In terms of communication, the OA-ICC provides a news stream with daily updates on the most recent research, ocean acidification related events, academic and career opportunity, and many others. We also have a dedicated website, and we produce a number of diverse publications targeting different types of audiences and using different types of outlets. We are also trying to be present at major international events and to maintain and further enhance relevant collaborations and partnerships. So the OA-ICC is part of a very wide global coordination network, and we are most grateful to our partners for their long-standing commitment. And it is due to the diversity of the members and the multidisciplinary and cross-sectoral nature of this global partnerships that a lot of important results have been achieved. And in the spirit of acknowledging long-standing partnerships, I will start with one of the most prominent activities in terms of addressing the socioeconomic impacts of ocean acidification that has been conducted over a very long period of time together with the Scientific Center of Monaco and the Prince Albert II Foundation. This has been triggered by the 2008 Monaco Declaration pronounced by His Serene Highness Prince Albert II as a result of his participation in the second International Symposium on the Ocean in a High CO2 World. And one of the focal points, one of the main points of this declaration was a call for enhanced collaboration between natural and social scientists. And in the further of this momentum, the IAEA and the Scientific Center of Monaco decided to establish a joint task force called the Monaco Environment and Economics Group, which laid the foundation of this series of important international workshops. These workshops have gathered prominent natural and social scientists representing tens of nations, starting from the first one in 2010. The first socioeconomics workshop titled Impacts of Ocean Acidification Towards an Economic Valuation was the first in this series, and it meant to identify existing knowledge gaps and to try to define methods to perform an economic valuation of the impacts of ocean acidification on marine ecosystems, translated into impacts on human populations and specific activities. The next workshop in 2012 focused on the sensitivity and resilience of key economically relevant species, vulnerability of markets, and also the adaptation potential of fisheries and aquaculture industry, working in 6 specific regions. The third workshop, which was conducted in 2015, focused on the socioeconomic impacts of ocean acidification on coastal communities, and mainly coastal communities depending on fisheries or aquaculture, or those depending on coral reef-based tourism. This workshop also emphasized the importance of biological, economic, and social modeling, design of effective adaptation and mitigation solutions, and important actions in governance and legislation. In 2017, the socioeconomic impacts workshop focused on ecosystem services and used the coral reefs as a particular case study. A series of solutions were presented for the short, medium, and long term, and for different levels of decision making, from local to national, regional, and international. Potential solutions were also designed according to the specificities of the regions, for example, the type of economic activities of the general level of development. And they were also categorized in 4 different categories: biochemical, socioeconomical, legal, and technological. After a break largely caused by the COVID-19 pandemic, the IAEA and the CSM, together with the Prince Albert II Foundation, will resume the International Socioeconomics of Ocean Acidification workshop with a new activity planned for the autumn of 2024 that will be focusing on pollution and ocean changes, impacts on and solution, and will be referring to the combined effects of marine pollution and the many ocean changes that are happening at a much faster rate. So it will be a focus on overall ocean health in a multiple stressor context, with its impacts on ecosystem services and also the economic costs of inaction. And this workshop is also meant to underpin the upcoming 3rd UN Ocean Conference to be held in Nice in 2025, to make sure this event bears a really transformative success. Each of these workshops translated into very comprehensive reports and also more compact summaries for policymakers, and all publications have become reference publications for the broader OA community and also for particular stakeholder groups such as decision makers and mass media. A different type of IAEA activities that address the socioeconomic impacts of ocean acidification are the IAEA coordinated research projects. They bring together research institutes from both developed and developing member states working on projects of common interest. So we are making sure there is a fair distribution of participation for the global north and the global south. The IAEA, under the auspices of the OA-ICC, has carried out 2 successful CRP projects involving a total of 25 IAEA member states, and the geographical coverage can be seen on the map marked in blue. So the first CRP, the first coordinated research project took place from 2012 to 2017 and was titled Ocean Acidification and the Economic Impact of Fisheries and on Coastal Society, and it was a first of its kind, really addressing, analyzing the anticipated effects at local and regional levels on fishery-dependent nations. And the project resulted in a number of successful products, such as a vulnerability analysis for marine regions and markets, and a vulnerability index that has been used to develop high-level scientific publications, technical documents, reports, and databases shared with the broader community in a free open access regime. The project has also developed regional economic models for impact pathways, a geographic information system tool for investigating regional scale distribution of geochemical and biological effects, and also the spatial effects on populations and economic activities. It has also allowed for the development and enhancement of research networks among participating institutions, and also it allowed for the review and consolidation of a multidisciplinary knowledge base, assessing existing gaps and recommending further enhancements. It also allowed for a replenishment of the OA scientific community, as more than 10 students managed to carry out their master and doctoral projects within the framework of this project. A second coordinated research project took place from 2018 to 2023 and focused on the impact of ocean acidification on seafood. It engaged 15 IAEA member states and worked to assess the quantitative and qualitative impacts of ocean acidification on 26 key seafood species. And it was a novel collaborative approach seeking to identify innovative ways of also applying nuclear and isotopic techniques to this field of study. And it sought to see if there were any common patterns of response in different species pertaining to the type of environment, the geographical location, and if any signs of adaptation could be identified in particular species. So the project is coming to an end this year, and a comprehensive report of activity will be provided in due course. So the interregional technical cooperation projects represent yet another avenue for the IAEA to address the broader socioeconomic impacts of ocean acidification. One successful project was carried out from 2016 to 2019 involving 18 IAEA member states. Another project will start in January 2024. And the exact number of participating member states is not yet known, but it will be made public in due course. So the interregional technical cooperation projects involve countries from different regions, but that share the same challenges, that are facing the same problems. And they seek to set global standards in terms of research methodology, but also to develop more simplified, more accessible research methodologies, and also to allow for really specific targeted capacity building based on specific needs existing in member states. It is also an avenue to develop and enhance interregional networking, found new collaboration efforts, and support common knowledge building, data sharing, and dissemination of scientific results. An important part of this type of projects is also the effective communication, so resultful outreach to key stakeholders in order to generate relevant policy action. So within the broader context of the UN Sustainable Development Agenda, the IAEA through the OA-ICC and other mechanisms supports action meant to address Sustainable Development Goal 14, and namely its target 14.3, minimize and address the impacts of ocean acidification, including through enhanced scientific cooperation at all levels. And in this sense, The IAEA, through the OA-ICC and otherwise, has become part of important initiatives such as Ocean Acidification Research for Sustainability, a UN Decade endorsed program, and the Communities of Ocean Action on Ocean Acidification, one of the 9 themed communities developed or initiated during the 2017 UN Ocean Conference. It is also important to mention that the OA-ICC has recently produced a policy brief based on the findings of the Intergovernmental Panel on Climate Change Working Groups 1, 2, and 3 that is available on the OA-ICC website.
Great, Olga.
Yes?
This is a 1-minute warning to wrap up. Thank you so much.
Yes, thank you very much. So just one last mention regarding the multitude of resources that the OA-ICC is offering the broader OA community. A small bibliographic overview exercise would help us see the evolution of literature in terms of research on the socioeconomic impacts of ocean acidification. We can see slight fluctuations in the number of publications over the past 18 years. So looking at the OA-ICC bibliographic database, the publications on the socioeconomic impacts of ocean acidification make close to 5% of the total number of publications. And we can also see that there are slight important geographical disparities in terms of where research is conducted, which also speaks of availability of research resources, which should be addressed. So in order to stick to the allotted time, I will thank you for your attention and invite you to submit any expressions of interest or questions you may have. Thank you very much.
Thank you, Olga, for this very interesting presentation. And it is always a pleasure to collaborate with you on the IAEA and the different topics that you presented, especially the workshop. And the next one will be in 2024. I look forward for it. Now the next presentation will be by Dr. Jason Hall-Spencer. He is the president of the British Ecological Society and professor of marine biology at the universities of Plymouth in UK and Tsukuba in Japan. He is also an adjunct professor at the Xiamen University in China. He conducts applied research to provide policymakers with the scientific information needed to best manage the marine environment. His main love is field work, but he also enjoys collaborating with other disciplines to help ensure that marine scientific research has societal relevance and impact. He has a PhD in seaweed biology and is now working on the effect of marine heat waves, acidification, and increased storminess in Japan and the Azores, and on the impact of a lack of biosecurity in the Suez Canal. He aims to provide information to help coastal communities adapt to the effects of ocean acidification and warming. Jason carries out work for many organizations, most recently the UN World Ocean Assessment 2, OSPAR, Kelp Forest Report, and advisor to the UK government on marine conservation zones. I know he's now in a different time zone, so thank you, Jason, for joining us. Your presentation will be on the economic service effects of ocean acidification. And the floor is yours. Thank you.
Thanks very much, Nathalie. And is it Punyasloke, my other chair? Thank you for hosting this talk. Now, let me see if I can share the screen a bit more effectively than I did earlier. How is that?
Yes, we can see your screen very well. Thank you.
Okay, big sigh of relief then. Well, yeah, thanks to all the organisers of this GOA-ON Ocean Acidification Week. I know it's a lot of work to get people from all over the world to do it, but I think it's good to keep this going because it stops people flying around to talk to each other, but yet keeps the conversation going and lets other people see what we're talking about all over the world. So it's a good format, and I'm pleased it's continuing. So as Nathalie said, I'm trying to address the situation of reducing ocean acidification by emphasizing the fact that by doing so will improve ecosystem services. I'm working mainly at the University of Plymouth, but also in the University of Tsukuba in Japan. And we've got this program running to which people are welcome to join, called the International CO2 Natural Analogues Network, ICONA. Now, it's really important, I think, to go back over the fact that we're just dealing with one ocean here. It's the only inhabitable planet we know of, and it's got one ocean on it. So there's this push to stop calling the different bits of the ocean, for example, the Atlantic Ocean, the Pacific Ocean, because what we do in one part of the ocean affects the other parts, and ocean acidification is a really clear example of that. It's interconnected, and it provides immeasurable benefits to humanity. Now, I'm going to be talking about ecosystem services, and this is one type of them, these regulatory processes, that really point to the fact that all life is dependent on the ocean. So, for example, it provides us with the oxygen we breathe, it regulates our temperature, it sequesters enormous amounts of carbon, it regulates the climate, it stops it getting too hot or too cold, and it's integral to the cycling of water and nutrients. Now, if you can't get more central to that in terms of keeping the life on Earth inhabitable, the ocean is absolutely key to the whole thing. It shapes conditions to allow them to be favourable for life. Oh, trying to go down. Yep, good. Now, what I spent a large part of my career doing is saying that if we continue along the route we are, these are the risks, these are the costs, and these are the ways in which we're going to damage the ocean and damage ecosystem services. But more recently, I've decided to turn the whole thing around because it's much more persuasive to say, well, by reducing CO2 emissions, we can get benefits that accrue from less acidification, less warming, less oxygen loss, less sea level rise, because they're all related to cutting back on CO2 emissions. And if we do the extra bit, which is causing less damage to the sea, for example, by stopping raw sewage going into it near cities or stopping the worst types of damaging fishing activity, then that will lead to improved ecosystem services from the sea. And what I think should probably happen in one of the next iterations of these socio-economic meetings is some attention paid to focusing on these economic and social benefits of complying with the Convention on Biodiversity or complying with the Paris Agreement. Just setting out, rather than saying how bad it could become, instead saying how good it could be for jobs, human health, and everything else if we were to stick to these commitments. So I think that would be an enjoyable thing to do going forwards in these types of workshops. So this talk that I'm giving now links to the GOA-ON natural analog session that there was on the 30th of October earlier this week. And it follows up on a talk I gave that's recorded back in 2020, which focused on the work by the second from the left there, Silvan Agostini. He spearheaded a project looking at the combined effects of ocean acidification and warming, because of course the two are happening together at the same time. And here's some more people from the team in Japan. So that's Ben Harvey, Kazura Inaba, and Shigeki Wada. And looking out there, it's looking out to sea from a marine station in Japan, where we've seen very radical changes in the ecology of the sea and its impacts on fishermen in the last 2 years. I'll come back to that later. So like I said, you can't consider ocean acidification on its own, because this is what's happening as well. It's a really big issue. You've probably seen these climate stripes on Twitter or X about the atmosphere and the temperature on land, but this one's focusing in on the sea and basically saying that since 1960, it's been getting hotter, especially in the top 500 meters of the ocean and now it's super hot. In fact, 2023 is going to be the hottest surface ocean temperature ever recorded, and it's having major impacts. So clearly, this is getting very, very serious. I was in North Africa this summer when the temperatures were exceeding, well above 40 degrees, really unpleasant. People were homeless and, in a really bad way health-wise because of this extreme heat that the country was experiencing, much beyond what is normally the case. Now, I say it's getting serious. So in Japan, where we're working, they lost 70% of their largest coral reef, which died thanks to a recent marine heat wave, which is obviously tragic. And the same sort of thing is happening on the Great Barrier Reef as well. So what we're doing is we're using volcanic carbon dioxide seeps, where CO2 bubbles out of the seabed, and other natural analogues. So these are other places that have got futuristic conditions. For example, some fjords have got futuristic conditions to assess the effects of ocean acidification and warming on ecosystem services. And those services are what people care about. So in a maritime nation like Japan, or a maritime nation like the UK, there are valuable fisheries, massive aquaculture and potential for more aquaculture, marine tourism, coastal protection, and so on. And if I had longer, I would show you nice pictures of people earning money and being happy pursuing these types of economic activities. The reason for this slide is to show you that Japan is a very large island archipelago that goes from far in the north, where it's cold and has got kelp forests, right down to the low latitudes where it's warm and has got coral reefs. Now, people are clinging to the hope that simply warming the ocean is going to cause and put in train a process called tropicalization, which this slide is kind of summing up in a jokey way, that you might think of things being wonderful as the oceans become more tropical. And it's certainly true that the fish of the Mediterranean or the fish of the coast of Japan are getting more warm water species. So angelfish or lionfish or trumpet fish, the fish that you associate with warm waters, they are moving north. That's certainly the case. But that's not the whole picture. And what we see when we look at the whole of the environment is actually a simplification of the ecosystem, not a tropicalization. So this is what is happening on a transect south of Japan. These are different monitoring stations, basically showing you that the pH of the water is dropping. And as most of this audience will know, that means that the carbonate concentration of the water is dropping all of those locations to the south of Japan. And it's measurable, it's happening, and it's happening rapidly. So what we're doing is using this quite small research vessel based at Shimoda Marine Station in Japan to look at what the ecosystem services effects are of this ocean acidification and warming, okay? And fundamentally what we see is overall habitat degradation. We've also interviewed fishermen who've been experiencing this over the last 5 or 6 years to see what their thoughts are on how things are changing and changing rapidly. Now, one of the biggest things that's going on, and I said just in the last couple of years, we've been seeing big changes. I hope like this will play, yeah. I was hoping to fast forward it a bit further, but what we're seeing is actually in front of the marine station where we're working, is that what was a kelp forest just 4 years ago has now been completely decimated by this tropicalization of the fish fauna. So that fish there is a parrotfish, which would never in its life normally come into contact with kelp because it lives in warm waters where there's corals. But because the water off Shimoda Marine Station is getting hotter, these parrotfish are moving in, and they quickly munched through and decimated the big kelp forests were there. And the reason that's important is because fishermen rely on the kelp forest for the seafood they capture and sell in the fish markets of Tokyo. They designed their whole fishery around the kelp forests that are there. And just within 2 years, this has simply disappeared. So this is a bit of IPCC intergovernmental panel climate change jargon here about the future. RCP 8.5 2100 is where we think we'll be by the year 2100 if we carry on burning fossil fuels at the rate at which fossil fuel companies would like us to. And along the bottom of the graph there, you've got microatmospheres, and along the y-axis, you've got temperature. And basically what we're trying to say with this work is that if we move back from that scenario to a future that we want, that is cooler and has got less CO2, then they'll accrue all sorts of ecosystem benefits. Now, this pie chart is basically showing you the types of ecosystem benefits I'm talking about. So provision of food is a key one, of course. The productivity of a system, or the ability of the system to protect coastlines from big storms and coastal erosion. These are all parts of the socio-economic picture. And we've compared data from temperate systems, tropical systems, and subtropical systems to see how this set of ecosystem services is affected by ocean acidification and warming. And just before I forget, effectively, if you lower CO2 emissions, you get less nuisance species, things like invasive species, or things like stinging jellyfish, basically things you don't want in the water, like toxic algal blooms. They all increase with CO2 and they decrease as you decrease the CO2 in the water. So here's a look at one of our sites that represents the future. It's warmer than the coastline is off Shimoda Marine Laboratory, and it's got higher carbon dioxide in the water because of volcanic activity. And the take-home messages here is there are fewer shellfish, fewer fish, there's less habitat complexity, there's less coastal protection because there's no coral and there's no kelp, and it's less attractive for tourism because it just looks like a barren seascape. Whereas if we reduce CO2 emissions, we can look at places that are like that and have got the temperate future that we actually want, with cooler water temperatures and more carbonate in the water. And in those places, you've got more abundant shellfish, more abundant fish, greater habitat complexity, as you can see in the picture, more coastal protection because there's extensive kelp forest that takes out the strength of the typhoons, and it's good conditions for aquaculture generally. There's work that we did kind of copying really what Sam Dupont did in Sweden, looking at the benefits to be had from reducing carbon dioxide levels on shellfish. And basically you get more abundant, tastier, and more nutritious shellfish at lower ocean acidification conditions and less stress from warming. So that's a PhD student's piece of work. And then if you go to places that are tropical, yet have reduced CO2 emissions, there that you get enough carbonate in the water and a lack of deadly heat waves such that you've got more abundant fish, greater habitat complexity, much more coastal protection from the reefs and the mangroves, etc. And that's all good for people as well. And so the local communities there are used to making a living under those conditions. And so by reducing CO2 emissions, we get back to those beneficial conditions for the people. So on the left there is a pie chart showing you a small cake with business as usual 2030 conditions. And then the ambition, if we actually reduce CO2 emissions and help rebuild biodiversity, by doing that, we increase that pie. So on the right-hand side, you've got greater productivity, more biodiversity, more opportunities for pleasant recreation that's good for mental health, more materials, more food, etc. But what's needed, I think, amongst the social economists is this shift towards saying how good it's going to be if we make the right choices, rather than saying how bad it's going to be if we don't, because that's more motivational. So something that's about what's in it for me could actually help with the industries involved in terms of reducing their CO2 emissions. So,
Jason,
yeah.
2-minute warning. Thank you so much.
Okay, I'm very nearly finished. So just to wrap up then, basically the clear messages are all life is dependent on the ocean, and that by harming the ocean, we harm ourselves. Ocean and climate action must be taken together, and reversing ocean change needs action now. So we can't kick this into long grass and wait for the next political cycle. So there's an organization that I'm helping called the International Programme for the State of the Ocean, trying to, through various fora, basically make these clear points. For example, reversing ocean change needs action now. So that's just to flag up really the ICONA project, what we're about, what we're trying to do with these natural analogues. It's led by Japan with partners in France and Italy. And we are now one of these Ocean Decade programs under the umbrella of GO-ON. So we thank the big brothers, if you like, of the UN helping us moving the direction and get our message over. So with that, I'll stop sharing. Thank you.
Thank you, Jason, for this very good presentation as usual. Thank you for being with us. I know it's very late for you. And now I move on to our next presenter, who is Sam Dupont. Dr. Sam Dupont is an associate professor and senior lecturer in marine ecophysiology at the University of Gothenburg and a consultant for the Ocean Acidification International Coordination Center of the IAEA. His main research focus is the effect of global changes such as ocean acidification and warming on marine ecosystems. He is based at the marine station of Kristineberg on the west coast of Sweden, where he performs experiments to develop solutions to address and minimize the impacts of global changes. He has published more than 200 publications on the subject in scientific journals. Sam is also working on the development of innovative science communication and education strategy to tackle global challenges through his role as a steering committee member of the Center of Collective Action Research, or his contribution to the latest report of International Panel for Climate Change. The third aspect of his work aims to evaluating and building capacities for marine science in developing countries. Today, Sam is going to tell us about ocean acidification and human health. Sam, the floor is yours.
Thank you very much. So let me share my screen. Here we go. So thanks, Nathalie. Thanks, everybody, for being here. So Nathalie asked me to join this session. She wanted me to talk about socio-economic as is the theme of the session, and I convinced her that maybe I could try to talk about something else. So what I'm going to talk about today is a different angle to the same problem. It's basically the contribution of ocean acidification on human health. So just to summarize a little bit, what you all know is that we are at the stage of ocean acidification research where we know a lot. We know the phrasing of the IPCC is extremely clear. We are virtually certain that there will be negative consequences of acidification, and Jason showed a really clear example that it's already happening. So that has been studied by different line of evidence, from paleo records, study in the lab, study in the field, and so on. And we know from all these different lines of evidence that there is a catastrophe in front of us if we don't take actions as soon as possible. And I really like the phrasing of Greta Thunberg, the Swedish activist, saying that basically the house is on fire and we need to act right now. So as scientists, we tend sometimes to congratulate ourselves. And it's true that the field of acidification is quite successful. In a couple of decades, we achieved a lot. We have like international networks. We have recognition at the policy level because acidification has been included in the Sustainable Development Goals. And in terms of science, we reach more than 10,000 publications now. So the field is well organized. We published a lot, and it is quite visible. But if we really want to be critical, we can realize that none of that had any visible effect on our carbon dioxide emissions. It keeps increasing, and over the last 20 years, nothing changed. And it started to get really worrying. Like this year has been a good example of how bad it can be. The graph on the left shows you like how temperature is getting warmer and warmer, and even more important, we have more and more of these heat waves and extreme events. So we are reaching a point where it's really, really scary. there has been like a reassessment of the carbon budget we have, at basically what they say is that we have 6 years of emissions left at the rate we are having today before crossing the line and not being able to basically reach the Paris agreements. So nothing is really changing. And what is really frustrating for people like me or Jason and others is that we told you so that it will be a problem for a long time. I published my first paper in 2008, and we said basically on studying the little brittle star that you have on the picture that if we don't cut carbon dioxide emission, they will be gone within a few decades. And this has been communicated in a very powerful way that was, for example, included in the exhibition of the Monterey Bay Aquarium, where there was a clear, strong message about these things. And what happened? Well, that species that used to be extremely abundant in Sweden, like you had hundreds of individual per square meter, is now gone. So you just can't find it anymore. So things are changing. We've been screaming the same thing forever. So why are we failing in a way as a community? And to repeat a little bit what Jason said, there's maybe like an issue of communicating the issue. There is a low ocean literacy, so not everyone knows that without the ocean, we would not be able to survive as a species. The ocean is providing us with all these services, from the air we breathe, some medicines that are produced, some the seafood, of course, there are cultural values, the unique biodiversity. You have groups that are only in the ocean, coastal protection, and the weather, basically all the services that Jason mentioned. And the way it's been communicated so far is really in terms of services. So we exploit, we need the ocean to exploit, to use it, and so on, for all these 4 categories of ecosystem services. And most of the time we use money as a currency to say, okay, there will be a cost if we don't do that. Are we going to gain money if we do this? It all comes to money, because money is running the world, of course. But I was really reflecting on that in the light of the fact that we are failing as a scientific community. Is really money the currency we need to drive change? And you have like really scary numbers that are thrown out there. Like, for example, you had this evaluation of the economic cost of acidification, and we talk about $300 billion per year. So that's massive numbers. But then I was reading recently some paper on the psychology of communication. And what psychology showed is that if you use money as a way to communicate, and that you put money in the head of people, that would make them less willing to actually be active, that they will be more selfish, they will be more self-centered. So using money as a tool to communicate about these issues has a side effect. The side effect is that we are maybe putting ourselves in a mental state that will make us less willing to do something about it. So what is the alternative? And I think something that I want to try to convince you today is that maybe we should use another currency, and maybe health is one. I've been part of this growing movement called Ocean and Human Health, and here are 2 references that you can have a look at. We've just published a book on that. With Laura Falkenberg, we basically wrote 2 scientific papers and a chapter just on that, like what could be the impact of acidification on human health, and can we use that as another way of communicating about these issues? Because there is a really close relationship between the ocean and human health. So if you ask to a medical doctor today, what is the main cause of mortality, like related to not violent mortality? It's basically obesity. And obesity is caused by a lot of different factors, from what you eat, the lack of exercise, mental stress, genetic, medication, and culture. And some of the best options we have to fix these issues is the ocean. Seafood-based diet is the only properly documented diet that has a positive effect on obesity. Recreation and biodiversity has a positive effect on your level of activity and mental health. And there's tons of medicines out there that needs to be discovered. So within this group of ocean and human health, what we did is try to see all these complex connections that the ocean has with us through this lens of health. So showing that if we don't cut carbon dioxide emission, we're going to suffer from unhealth. And if we do something about it, we will benefit from a better health. And we published a couple of years ago the strategic research agenda to see what can be actually done. So let's refocus on acidification now. Acidification has no direct impact on our health. pH in the swimming pool is much lower than the ocean is or will be. So we don't have to worry about that. However, the oceanification has a lot of indirect effect on things that will have an impact on our health. And we identified these 4 different pathways. So I'm going to go quickly through these 4 pathways now. The first pathway is kind of obvious, it's food. So we need food, we need high quality food, and Jason mentioned that too. So it's about quantity, but also in terms of quality, to have access to nutritious and healthy food. There are some potential negative effects. Also, acidification might increase the contamination. So acidification can have a negative effect by decreasing the quantity and quality of the seafood, but also increase the level of contamination and also increase the level of toxins. For example, you can have harmful algal blooms, and some of these toxins will accumulate in the food we eat, and that can lead to malnutrition and poisoning. So in that case, we have different pathways in which acidification can impact our health. Another one is respiratory issues. Again, harmful algal blooms can release toxin in the air that can have strong negative effect on local coastal communities. So you have respiratory issues there. Another more interesting pathways, I would say, is through mental health. So there's a growing psychological literature showing that the closer you are to the ocean, the healthier you are mentally and physically. And acidification can challenge that through different ways, like create state of stress by losing your job. If you're a fisherman or working in aquaculture and your livelihood is challenged. It might also, by making the ocean more toxic, decrease potential for recreational activities. There's also this need of being connected with nature. And again, by destroying the habitat, we can impair this ability. So there are all these mental issues that acidification can also have a negative impact on. And the last pathway is through biodiversity. Something we know for sure is that acidification will decrease biodiversity, and there are tons of really interesting substances and processes related to that could be used, for example, for medicines and so on. One of the best anti-cancer substances that we have today that is tested at the moment on human trials is coming from an obscure sea cucumber that you see on the picture here that lives on the deep sea. And there are tons of other ones that we can use. So basically, by not caring about biodiversity, we might actually challenge our ability to develop these new antibiotics or alternatives medicines. So I was just really brief because we are a little bit short in time, it seems, but I went really fast. But basically, my point here is that there is a clear relationship between the ocean and our physical and mental health, and acidification will have indirect impact on all these processes in a very complex way. This is a figure from one of the paper. If you're interested to see more of the details, just go for it. But basically, for example, if the acidification has an impact on the seafood itself through the quantity and the quality, that will also have consequences for health, for example, indirectly to obesity, or indirectly to market changes or poisoning, and so on and so on. So it's a complex issue. But what I wanted to convey is that we know a lot. We know a lot about acidification. We know for 10 years that it's a big problem that needs to be addressed. We know what we need to do. We need to reduce carbon dioxide emission. What we need really is meaningful action, and that's really lacking, and we can see that through this continuous increase in carbon dioxide emissions. So I personally think that we should challenge the idea of using classical economic models as a way to communicate these things, and maybe go and use something that will speak a little bit better. Human health. You can't buy human health. I think you have to keep it. So it's not something, if you put a price on most of the things that are out there, people will be willing to pay. But if you're sick, there's not much you can do about it. So my challenging question for the group, and maybe something to discuss later, is, shall we consider human health rather than money as a new currency to communicate about these issues? And we can combine that with Jason's ideas of also coming with a positive twist, like the carrot instead of the stick. So thank you very much. I hope we're going to have time for questions later. And here again are the different documents that you can have a look at if you're interested in these fascinating issues. So thanks again, Nathalie, for giving me some time today, and looking forward to the discussion.
Thank you, Sam, for this very interesting communication. And yes, I think we have food for thought now to see if we can consider human health as independent from the economics, because also we can also consider, as an economist, I can tell you the cost of the impact of ocean acidification or climate change or pollution on the human health. So the human health is also something that we can monetize as economists. So this is just to give more ideas for the next question. And now we are moving to the next presentation. The next presentation is by Abed. And sorry. So, Dr. Abed Rahman Hassoun holds a PhD in oceanology, prepared between the University of Perpignan in France and the CNRS of Lebanon since 2014. He's currently a researcher at GEOMAR, Kiel, Germany, working on extracting gaps in the EU ocean observing system to provide actionable recommendations to the EU Commission. His main study area is the Mediterranean Sea. He is interested in long-term marine biogeochemical trends in the context of climate change. He is also interested in assessing impacts of climate change on biodiversity, mainly on phytoplankton and the occurrence of HABs. Dr. Hassoun worked as a consultant for the IAEA Monaco and the Ocean Frontiers Institute in Canada on topics related to ocean acidification and ocean carbon cycle. He is interested in bridging gaps between science and stakeholders, policymakers, to improve actions and protect marine ecosystems and ultimately vulnerable communities. He is the founder of the Ocean Acidification Mediterranean Hub and is a member of the GOA-ON Executive Council and the Euro Sea Gender and Diversity Board. Dr. Hassoun is a co-champion in Outcome 6 of the UN Ocean Decade Program, OA-ICC, and today he is going to present about the knowledge gaps about ocean acidification in the Mediterranean. The floor is yours, Abed.
Thank you so much, Nathalie, for inviting me to be here in this very interesting session, and thank you for everyone who's actually here. And yeah, I mean, when Nathalie invited me for this session, I was like, oh my God, what should I, what can I present? But yeah, I mean, this is a very nice opportunity to remind about the importance of socio-economic studies in an area like the Mediterranean Sea, and to study the different aspects, not only chemical and biological aspects of ocean acidification, but also to check how to understand the socio-economic impacts and maybe to boost the resources that are needed to better understand the effects of on the Mediterranean unique ecosystems in general. So why the Mediterranean, and why it's really interesting and very important to study the Mediterranean. So the interest in this sea started very early, since it's the cradle of many civilizations, from Phoenicians to Greeks, and also Romans who called it Mare Nostrum, our sea. So our sea actually is under multiple stressors related to things related to climate change, directly to climate change, but also to other anthropogenic activities like overfishing, etc. And we need to understand that the Mediterranean Sea actually has many resources that are crucial to many vulnerable communities that are relying on its resources like fishes, etc. And that means, so that's actually translated in terms of money. So, and the negative effects of ocean acidification and other stressors on its ecosystems would be drastic for many vulnerable communities that are living and relying on the Mediterranean Sea ecosystems. And in the latest FAO report, so we do have around one fisherman in every 100 coastal residents in some areas of the Mediterranean Sea, showing actually the vulnerability of these communities relying on the Mediterranean. But also the Mediterranean actually is harvesting more than 20% of seaborne trade, more than 10% of the world container through put and hosting more than 200 million passengers, and that's actually having so much negative effects like the CO2 emissions, litter, etc., etc. Based on the latest Mediterranean assessment by the MEDEC, so we can see clearly that in addition to direct anthropogenic pressures in the Mediterranean, we also have many negative effects related directly to climate change, and one of them is ocean acidification, and that has many effects on many key actually ecosystems that we rely on, and that would change, of course, the trophic relationships and has many effects on nurseries and thus on the fisheries, etc., etc. And these results were also in harmony with the results of the IPCC report dedicated. So one of the chapters was dedicated for the Mediterranean area, showing the high risk in the future as well on the marine ecosystem. So it's high to very high for an increase of more than 1 degree Celsius in the future. So showing that the Mediterranean area has to be better understood and that it's a high risk area as well. So why is that? Why we need to understand the Mediterranean? So the Mediterranean is representing around 0.80% of the planet's ocean surface. However, it's hosting around 1% of all known marine species. Here we are talking also about the wetlands, etc. And the risks are so high. So 50% of, for example, wetlands lost or degraded since 1970. And the coastal ecosystem that in the Mediterranean Sea are also threatened by so much activities like overfishing, invasive species, etc., that are exacerbated in our Mediterranean Sea. Again, these also are based on that report that are showing also that around 40% of endemic fish species could be extinct by the end of the century, also showing a high risk on the economic aspect of many Mediterranean countries relying on the sea. And this, we already also have seen that not only ocean acidification, but also ocean acidification in harmony with other, in parallel with other stressors like ocean warming as well, is also participating in the Mediterranean coral bleaching, in addition to many also other effects on many key groups. So what we are doing as a hub, so the OA Med Hub is one of the hubs, one of the GOA-ON hubs, 9 regional hubs. And we are dedicated for the Mediterranean Sea. And so we are gathering so far around 100 members from 14 countries to promote community best practices and support exchanges, etc. So we know who's doing what. We've launched a survey in order to know who's doing what, etc., and to identify ways of collaborations, etc. So now we know the gaps in each country. We know the gaps of observations of ocean acidification in each country, what each country is doing in terms of observations, sensors, etc. So I will not cite all the countries, but I want to say that as we are having new entries, we have to also check again to update our gaps, list of gaps in the Mediterranean Sea, in order to see also why many nations are not able so far to understand the socio-economic effect of ocean acidification and also of other stressors in parallel in the Mediterranean area. So in the hub, we are so much interested to close the gaps of the gender gap. However, one of the huge gaps is related to the North and South diversity, or let's say North and South affiliation of scientists. So this discrepancy is clearly related also to resources differences, which hinders a better investigation of ocean acidification in the South Mediterranean Sea, where actually more and more vulnerable communities are present. And this shows the importance also of better investigating the socio-economic effects of ocean acidification and stressors in these countries. So we've actually published a recent paper about ocean acidification research in the Mediterranean that was actually supported by the IAEA, by the OA-ICC. And it was the first systematic review article related to the Mediterranean Sea. So we've tackled many aspects of ocean acidification. So not only ocean acidification chemistry, but also the effects on socio-economic effects, also political effects, etc. What we've seen that there is an international interest in studying ocean acidification effect in the Mediterranean Sea, not only by Mediterranean countries. And what was actually very interesting to see also that the end of many pan-Mediterranean projects, the publications on Mediterranean on ocean acidification have been decreasing in the Mediterranean Sea, showing also the importance of collaborations in the Mediterranean to improve our observations and the understanding of a specific threat like ocean acidification. And here we can see clearly also the discrepancy between studying, between the east and west of the Mediterranean and studying in these two main basins. And what I wanted to show here, what was really also very interesting, that now we are talking so much about, for example, marine carbon dioxide removals worldwide in general, but also in the Mediterranean, there is only one study in the Mediterranean that is dedicated to study or to check, to investigate this approach in the Mediterranean, showing also that there is a huge gap. And regarding the socio-economic studies in the Mediterranean, they are so rare, also reflecting that this type of studies in the Med are lacking. In addition to that, the huge gap between the North and South Mediterranean countries is also have been highlighted in this publication as well. So it's not only the discrepancy between a chemical level, but also a biological level when studying the effects of ocean acidification on marine biological groups. We can see clearly that many key important biological groups are not really well studied in the Mediterranean, and they might have a significant effect on the functioning of Mediterranean ecosystems, like, for example, sponges, foraminifera, pteropods, microbes, viruses, etc. And we are still seeing that many articles, publications related to ocean acidification are only studying the effects of OA without actually having other stressors running in, without taking into consideration other stressors. And now we are living in a multi-stressor world. So having studying only ocean acidification solely is not realistic anymore. So regarding ocean acidification, socio-economy and policy, the problem of ocean acidification is being more and more recognized in the Mediterranean Sea political sphere. However, there are still so much things to be done. Unfortunately, the scientific and information is not being very well communicated to decision makers, to policy makers in the Med. And this is something that we are trying now to work on, but this is a huge gap. So we need to better valorize or to monetize the losses in the Mediterranean Sea, and maybe a new publication about the socio-economic effects in the Mediterranean would be also very helpful. So in the hub, we are trying also to communicate, the effects and the threats, the consequences of ocean acidification to our colleagues in the Mediterranean, in different Mediterranean institutes, to explain about the trends, to explain about the biological effects, what can be done, etc. And we are trying also to create like different ways and channels of communications and collaborations. And that's why in the latest BADAC report, I mean, we've been very well acknowledged that this is our hub is a way of is one of the ways to actually to beat a threat related to climate change, like for example ocean acidification, on through improving communication and collaborations and exchanges. So that's what I wanted to say so far. So supporting regional hubs is between scientists and to consolidate bridges of communication, especially now. So we need more and more collaboration, especially between scientists, economists, those who are working on policies, etc., to better communicate with policymakers, etc., on the effects and socio-economic effects as well. So I'm not gonna be so if you need anything, you can actually follow us on the social media, contact us, and thank you so much again.
Thank you, Abed, for your very good presentation, very interesting on the Mediterranean. And we are a bit behind the time, but we will try to continue with the last but not the least speaker. Dr. Nina Bednaršek holds a PhD from the University of East Anglia and postdocs from the University of Washington and NOAA PMEL. She is currently an assistant professor of research at the Cooperative Institute for Marine Resources Studies at the Oregon State University. She focuses on the interactions between ecological responses and the multiple climate change stressors, such as ocean acidification, warming, deoxygenation, and extreme events. Her work has led to the development and implementation of the early warning indicators related to ocean acidification and related to socio-economic implications. Her work now also focuses on the projects related to the investigation of the ocean's CO2 capture and the impact on the biological and geochemical processes. Also in her role of the INBER champion of the ocean solution, as well as a member of the Executive Committee for UN Ocean Decade for Ocean Sustainability Program Global Ocean Negative Carbon Emissions. Nina, thank you for being here, and the floor is yours.
Thank you, Nathalie, and thanks for having me here. I will present a recent aspect of various studies that have been done over the years, specifically for the Mediterranean Sea, and trying to really address the socioeconomic perspective and the importance of the governance within. So for a little bit of a background, but we all know it, we know that the chemistry is changing now at the unprecedented rate, biology as well. It's not something of a future scenarios, but everything that is being affected right now. And we are gaining quite a certainty across ecological and ecosystem scales, especially on the regional and local level. And of course, everything what's happening on the biological scales resonates across the socioeconomic scales and has important economic governance implications. But we do live in a time where solutions are badly needed. And for that, we need interdisciplinary approaches across natural to social sciences with very highly integrated and effective governance behind it. So in order to speak about the solution, we of course need to first understand the risks. And this is an IPCC risk assessment framework to delineate the risks, whereby the risk here is defined by the exposure and vulnerability that also encompasses adaptation as well in this. So going from the ocean chemistry and ocean global change, in this talk, I'm focusing on warming, oceanification, and marine heat waves specifically as an exposure elements wrapped into vulnerability. We can then define these disasters in order to go to the solutions And solutions really are a disaster risk management, adaptation, and mitigation strategies. And all that is actually encircled within the governance network as well. So focusing on the Mediterranean now, we know that the Mediterranean basin is basically undergoing rapid climate change. It has been identified as a climate change hotspot. Here is where the multiple climatic drivers are dynamic, interactive, highly complex in their action. In terms of temperature, the Med is exceeding global trends, with the mean temperature predicting to peak at 2.6 degrees under RCP 8.5 scenarios. We know that the marine heat waves, the frequency and the intensity of them are increasing, and the mass mortality events are happening to the scale where this represents a threat to the ecosystem's health and the functioning. And also fingerprinting now the OA in the Med shows that the anthropogenic signal is already detectable in over the entire Mediterranean Sea, along with all the marginal seas. But of course, there are significant east-west, north-south differences. Interestingly, that these stressors mutually reinforce each other. So, for example, warming with increased respiration and then eutrophication and lower buffering capacity of the Mediterranean waters all contribute to the OA intensification. So it's not something that we can leave it out and just talk about marine heat waves and the warming being predominant factors. Yes, they are, but along and compounded with the OA, this is a multi-stressor risks that we have to take into the framework when evaluating the risk. So on the biological and ecosystem level, there are severe negative impacts on highly vulnerable and ecologically and economically important ecosystems in the Med. So thinking about the biogenic habitats, the reefs, seagrass, CCAs, the biodiversity and ecosystem services that were talked about before. And the problem really in the Med, in this highly interrelated and interconnected system, is that the climate-related stressors strongly overlap with the vulnerable and or protected habitats and zones of intense economic activities and those economic services. And that represents a real governance challenge. And the governance then links to the socio-ecological and economic systems. Why? Because the aquaculture and the fisheries are really one of the economic significance pillars here in the Med. Aquaculture is really one of the fastest growing food production, and the fisheries and reliability on the fisheries, specifically in the southern poor regions, is immense and really important for the economies of the several Mediterranean countries. So then the BANA management here relies on improved multi-stressor response understanding. So in the next slides, I just wanted to show you a couple of studies that we have done in the last years that might bring a little bit better understanding of what options, and especially adaptation options, are possible, specifically focusing now on the species that contribute to the aquaculture. So wanting to basically link different exposure regimes that encompass ocean acidification, warming, and marine heat waves, either under current or RCP 8.5 2100 regimes. We were investigating energetics and immune responses on the blue mussel, and we had the 3-month exposures experiments along with the recovery period. So after the stress exposure, these organisms were also exposed to a 2-week recovery period or no stress period in order to figure out if there is a subsequent recovery on this. We also mimicked the marine heat waves where we were gradually increasing the temperature of the water and seeing then these responses under this kind of stress. And the main idea is to use the biomarker, something that we can use experimentally and in the field to detect the cellular stress and also mitochondrial energy activation to basically see if the organisms are in the state where they can still basically respond to their basic or additional energy needs, or that point, that threshold has already been crossed. So first, I just wanted to take you on this energetics of the muscles. And with that, we have been exploring the hepatopancreas tissue. And we know that in the muscles, that tissue is basically responsible for food digestion, lipids, glycogen storage. And on these graphs, you will see the red arrows indicating the stress, and the blue lines and arrows indicating the post-stress or the absence of stress, where we were investigating the recovery. And so basically what we find out on a broader organism scale in terms of energetic is that the muscles basically between the months 2 and 3, they go into metabolic shutdown, and cellular production is insufficient and reduced to the very baseline levels. And so we have seen that the biomarkers we have used to demonstrate if the cellular energy, mitochondrial energy, is still active or not, we have seen that this no longer provides the energy needed during the stress exposure. So that's graph on the left. But the graphs on the right actually gives us more insight on how the prolonged exposure of 3 months, and this is something that is currently expected to be happening in the mad waters, in the surface and subsurface waters, that this temperature actually represents the main stressor, where the muscles are completely exhausting their proteins and lipids. And it seems that after 3 months, the temperature is the main stressor. But in the process of exhausting these lipids, pH plays equal role, and even during the duration of 2 months, we have seen an exhaustion of lipids under the pH treatments. When it comes to the entire energy reserves, under such a long duration of the stress, a post-stress or absence of stress subsequently simply does not allow the organisms for any energetic recuperation. But we have seen that maybe with a shorter exposure where we were mimicking marine heat waves, that still allows the organisms to be responding to increase their cellular energetic activities. So it really does matter for how long you expose these organisms to. But when it comes to the immune response classification, so specific impairment pathways, we have seen very different things. Basically, it doesn't matter that the organisms have been exposed to such a long duration. 3 months is a relatively long duration. The organisms would still have very intense mitochondrial, cellular, energetic activity across all the treatments. So for lower pH, warming, marine heat waves, and we have observed this in all tissues. So when it comes to the immunological functions, calcification, respiration, where pH has a more explicit OA effect, specifically in the combination with the warming, the cells do not shut down their functions. They keep on going. So obviously they are preferentially investing their energy into the processes that are needed for growth, for their own protection. And even more, what is extremely important here is that the post-stress, so no stress treatments, show consistent recovery for various impairment pathways. And despite this energetic exhaustion, organisms can quickly activate their mitochondria, their energy, and that is very important for the quick recovery. That is the first steps in order to start gaining more energy to activate this the pathways that might have been impaired during different stress exposures. All right, the other study is basically from the field work, where we also wanted to see what sort of treatments we could have in order to facilitate or alleviate stress for the muscles. And this was a co-cultivation with the kelp and oysters and also the bivalves. So we were having the mesocosms within the kelp and comparatively as a control in the outside of the kelp as well. And what we have observed that within the kelp, we always had positive biological responses in all organisms. And we think that that is due to a couple of different sources. So improved responses maybe to the cumulative increase in pH over time, increased food availability, so feeding on kelp or macroalgae, and then also increased predictability. And some of these parameters are fairly novel. I don't think that a lot of studies are positioning their investigations studying this sort of response, but they're extremely useful when we talk about the habitat suitability and what sort of management options we have when it comes to aquaculture sustainability. So when it comes to the strategies, I think it's very important that we first and foremost consider that OA is really important stressors and should be delineated as one of the stressors. Of course, it should not be all the climate-related stressors, but we have to position this in the multi-stressor risk assessment. And this needs to be, so the risk evaluations needs to be done for the current state and also for the near future conditions in order to start supporting and facilitate the action steps. We have seen, for example, that the recovery in the absence of stress does happen, but that also helps us think about how we can delineate different habitats where the stress alternates. So those are the habitats with some stress, with no stress. And in that matter, the frequency and the duration of the exposure really does matter. For that, we have to develop some maybe more quicker metrics to develop cellular stress. And it's really important to develop more high resolution observations and link that to the modeling as well. So we want to investigate the strategies on a local level. But then, of course, this comes into the larger umbrella under mitigation and adaptation interventions. And some of the techniques already mentioned is maybe co-culturing with the macroalgae, increased food availability, and ocean alkalinity enhancements. So I think in the future for the aquaculture and the fisheries is bleak. But it is possible in these tightly selected habitats, especially if we start thinking of how the potential MCDRs would impact the aquaculture. We always have to think that reversing is not only for the ecological, but also for the socioeconomic benefits. But this does require a very effective ecosystem management and the governance. The governance in the Mediterranean is an entire whole issue because it's highly fragmented in terms of sectoral institutions and the spatial zonations, both within and beyond the natural jurisdictions. That really fragmented governance that is inefficient is further compounded by a linear and state-centric approach instead of, over-basin centric approaches. And as such, is really unsuited to address the prevailing socioeconomic challenges and also these cascading risks from the climate change. And some people and some scientists refer to the governance gap, where it's really the lack of dedicated and integrated policy, along with the clear institutional mandates and legally binding objectives that doesn't get us anywhere. So in effect, what you see on this picture, what we should be doing right now is really intense research monitoring, prevention and mitigation, and start thinking about really sectorial adaptation in order to prepare for the future positioning of this adaptive management and governance and socioeconomic resilience. We are not doing anything. And the main obstacle in the entire issue is the governance. So how can we think about the solutions?
1-minute warning. Thank you so much.
That will go into the governance. Of course, the prevention first and foremost. But in the lack of that, we have to invest into the research and the monitoring, empirical observations, interactions of the multiple stressors. We have to think about adaptation and resilience across the entire natural social systems, diversification, fisheries management. We have to start including the economic evaluations of this. And then, of course, the adaptive management and the governance is crucial. So really effective cooperation between the state and non-state, develop the polycentricity and the redundancy into this. And I just wanted to show you, because we have been talking about the different ORS strategies, but here coming from the IMBER perspective, when we have a specific challenge for innovation challenge for the mitigation and adaptation strategies, we think that the governance is really a key at all this. And the best practices, development of the methods that can scale from pilot to full-scale operational interventions. Some decision rules like thresholds, and these are not just ecological thresholds, but political, societal, environmental thresholds that can spur the actions. And then really understanding and enhancing the governance framework are all targeted at minimizing the risks, because interventions could be risky, of course, but the governance is there to reduce those risks. And of course, the questions around the governance that we need to ask is, what is an appropriate, what is the equitable governance on these interventions, and which are actually social acceptable? That cannot be a silo of the science to be basically having that conversation alone, but needs to be in a close collaboration with the governance as well. So maybe just additional perspective from the IMBER in how we are looking at the interventions currently and what needs to be done. All right, thank you so much for giving me this opportunity to talk today. Thank you.
Thank you, Nina. A very interesting talk, and maybe you have a question in the chat. Maybe you would like to respond directly. We don't have a lot of time, but I want to thank you all. In this section, we had great examples of the link between natural and social sciences. We need both to understand the socio-economic impacts of ocean acidification. The economic valuation should be science-based, and we had very good presentation showing that many institutions are involved in this multidisciplinary research. Thank you, Olga, Jason, Sam, Abed, and Nina for your amazing presentations. And big thanks to the organizing of this OA week, especially Sarah and Yume. And thank you to all for being online. I think we have to close this session, unfortunately, but we can continue offline to discuss together. Thank you so much.
We would like to thank the organizers, moderators, and the speakers for a great session. And we thank you, the audience, for joining us for OA Week 2023. Please don't forget to consult the website and register for the next session. If you would like to stay up to date, with GOA-ON community, consider signing up as GOA-ON member. To discover more about ocean acidification research for sustainability, please scan this QR code. Thank you all and see you next time. Goodbye.